Okay, so we are going to talk about algebra, and we're just going to go over an introduction of everything that we need to know, first of all, and then the other videos will go through, the other things that we've gone through in class. But just kind of starting off with basic introduction. What is algebra? What are the things that we need to know? Okay, so you should be kind of familiar, I should have seen before, that symbols like this, okay, we might have seen sums like this one here, where it's triangle plus 8 is equal to 12. And we kind of just work it out by saying, okay, well, something plus 8 is equal to 12, so then the triangle must be equal to 4. Okay? And then we can use that in other sums. So if you were told, like down at the bottom here, circle is equal to 7, then 6 multiplied by circle is going to be the same as 6 multiplied by 7, and that's 42. Algebra is actually this, okay? In its most basic form, this is what we would consider algebra to be. It's all about looking for numbers that we don't know and representing those using symbols. And typically with algebra, with most of the algebra we'll be doing, the symbols that you're going to use are just going to be letters, okay? But these sort of sums that you have seen before and that you would be able to do, those are the most basic form of algebra. So just remember that if we're getting confused or if we're not sure what's happening, come back to these sort of questions. Okay, remember that any of the letters we look at is the same as any of these shapes that we're seeing here. So each letter or each shape or each symbol stands for a number. Okay, so there's some key terms we need to go through, or some key words. The first one is a variable, and a variable is a letter which stands for a number that we don't know yet. Okay, so it has a value, we just don't know what it is. So x is probably the most common variable that you're going to see, but it could be any letter, and it just stands for some number. Okay, a constant then is a number that is fixed and it cannot change. So variable comes from the word like vary. So if something varies, it changes. If something is constant, it doesn't change. It's fixed. Okay, an expression then is a mathematical sentence that's made up of variables and constants. So an expression is going to be kind of just like a sentence, it's laid out in that way, and we can think of it as being kind of separated by your pluses and your minuses, your operators, okay? And this expression is made up of your variables and your constants and kind of put together in particular ways. The parts of an expression are called a term, okay? Each part of an expression is called a term, and the terms are separated by your plus or your minus, okay, usually. So a term might be 4, a term might be x, a term might be 3y. Here we're going to see lots of different types of terms and expressions. So in the next little part, this is an example of an expression, 2x plus 3y plus 4. Okay, this is an example of one of these mathematical sentences that we're going to be looking at. And we'll see as well that it doesn't have an equal sign yet. And what that means is we don't have an actual value for that. So it's just kind of a statement. Okay. So an expression containing 3 terms, so our terms are 2x, 3y and 4. We don't know the values of x and y, and also x and y could have different values in another expression. So if we find out that x is 2 during one question, that does not mean that in the next question x is still 2. And that's why they're called variables, because they can change. What we're pointing at here as well is the number 4 is the constant, okay, because it doesn't change. No matter what x or y is, 4 will always be 4. So it's constant. If we have something like 2x, the number 2 tells us how many x's there are. So if I was saying how many x's are there, we say there's 2 x's. If I said how many y's are there are 3 y's. Okay, and that's important as well when we get on to some of the other questions, just that kind of phrasing. So how many x's, we look at the number in front of it, and that number is called the coefficient. Okay, I know there's a lot of words here, but it's just important that you've kind of heard them all. So the coefficient is the number in front of x, in front of the variable, and similarly then 3 is the coefficient of y, and it tells us how many of those letters we have. Okay, so we have 3 y's, we have 2 x's. Notation wise, in terms of algebra, we don't generally use the symbol for multiply and divide. Okay, and it's fairly straightforward. A lot of the time we don't use the symbol for multiply because the symbol for multiply looks too much like an x. Now we will see that we maybe write our x's slightly differently, or I'll definitely write them slightly differently here than just a normal x, but it just keeps it really, really clear, and it keeps it a lot cleaner as well. It reduces kind of how complicated the sum looks. So instead of using a multiply or a divide sign, we just write them a bit simpler. So instead of writing 2 multiplied by k, all that we write it as is just 2k. But it's important that we know, looking at that if we see 2k, we know that that means 2 multiplied by k. Okay, so that's really important, that we can look at 2k and remember that that means 2 multiplied by k. But we'll generally just write it as 2k. And in the same way then, if we've a over b, we usually write that instead of a divided by b, just to keep things simpler for us. Okay, it makes it look a lot cleaner. So something we're going to get onto a little bit is x plus x plus x. How many x's are there? Well, there's 1, 2, 3. And we said before that the number in front just tells us how many there are. So there are 3 altogether. So there are 3 x's. Okay. The next part, 2 multiplied by a multiplied by b. But from what we've just said, 2 multiplied by a would give me 2a. So I would have 2a multiplied by b. And the same thing again, we just get rid of the multiply sign. So I get 2ab. We see the same thing in the next one, 4 multiplied by x multiplied by y multiplied by 3. What they've done with this one is they've changed the order. And that's okay with multiplication. We don't have to multiply them in the same order. We kind of know already, if I do 3 multiplied by 2 and I do 2 multiplied by 3, they're going to be the same. Because multiplication is what we call commutative. We can swap the order of them, but we'll still get the same answer. So instead of having the 4 here and the 3 at the end, we can move it around and have 4 multiplied by 3 at the start here. And what we get then, 4 multiplied by 3 is 12, and then we get 12xy as our answer, just getting rid of those multiply signs. And we have something similar in the last part. So you can see that instead of writing 2 multiplied by a multiplied by b multiplied by c, it's just a lot cleaner. You just write 2abc. Okay. 2 last little points that are important are these parts here. So 1x is just written as x. Okay, so instead of writing the 1 in front of it, we usually just leave it out, just write it as x. And if we have 1x plus 1y, then we would just write that as x plus y. Okay, again, keeping things as clean as we possibly can. So let's look at how this kind of works then in practice. So if John has 8 DVDs and he buys some more, how many does he have now? Well, we haven't been told how many, we've just been told some more. So that would be what we would consider an unknown. Okay, we don't know how many he bought. He had 8, he bought some more. So if we have a number that we don't know, what we generally do is represent it by a variable. So we would say that he has maybe 8 plus x. Okay, so x is some number, it's the sum more, and we don't just know what it is. So we do 8 plus x. In the same vein then, for the second part, John goes back the next day and buys the same number of DVDs again. Okay, how many does he have in total? Well, from the first day, he has 8 plus x, and he's gone back and bought the same amount again. So he has bought x more. Okay, but that's not the simplest way that we could write that. And we need to kind of look back at what we said earlier. The number in front of the x's tells us how many we have. So how many x's do we have here? Well, we have 1 and we have 2. So altogether we could write it as 8 plus my 2 x's. Okay, so 8 plus 2x, and that's how many DVDs he has altogether. So depending on what x is, depending on how many the sum was, that sum would be different, that answer would be different. And this leads us on to the next little thing that we need to know, which is about adding like terms. Okay? An expression like this one here, x plus 2 plus 5, has what we would consider 4 terms. Okay? The expression can be made simpler if we want, 2x plus 7, which is 2 terms. And that's always what we're aiming for, something a bit shorter that doesn't have as many terms. Okay? So the x plus x can be added to give 2x. And why is that? Well, we said that before. If we look and see how many x's do I have? Well, I have 1 and I have 2. So altogether, 2x. And these can be added because they're called like terms. And like terms are terms with the same variable. Okay, so it's terms with the same variable or letter. Okay, and that's explained a little bit more below. So if we had something like this, 3 cars plus 2 cars would be 5 cars, but 3 vans plus 2 cars can't be made any simpler. We can't say that's 5 vans, we can't say it's 5 cars, it's 3 vans and 2 cars. In algebra, we can only add things that have the same letter. So we could add 2x plus 3x, and how many x's would we have in total? 5x altogether. But if we have something like 5x and 7y, we can't make that any simpler. Because if we think about it as we've kind of been doing, how many x's do I have? I have 5. How many y's do I have? I have 7. But we can't add those together. We can't say that's 13x or 12x. We can't make it any simpler. Okay, they're what we would consider unlike terms because they have different letters. So let's try and apply that in an example or two here just to make sure we kind of understand it. So if we look at the first one, remember, like terms mean they have the same letters. So like terms here mean the same letters. So we look at the first one. How many x's do we have? Well, here we remember that if we have x written on its own with no number in front of it, that's the same as just 1x. So I have 1x there, I have 2 x's here, so altogether 1 plus 2, I have 3x. We look at the y's, I have 3y here, I have 5y here, so altogether I have 8y. And that's as far as I can go with that question. I can't go any further because I can't add x and y because they're unlike terms. We look at the next part, 3a plus 4b minus a plus 2b plus 2a. So let's focus on the a's first. I have 3a here, I have minus a here, and I have 2a here. So if we think about this sum, I have 3a, I take away 1a, so that gives me 2a, and then I add on 2 more a, so altogether I have 4a. We look at the b's, then I have 4b plus 2b, which gives me 6b. And again, we can't go any further because those are unlike terms. We look at the next one. So we have p's and q's and r's. Okay, so let's focus on the p first. I have 2p plus p, so altogether 3p. We look at the q's. I have 3q minus 4q. 3q minus 4q, and this is where we have to bring back our rules of integers. 3 minus 4 gives me an answer of minus 1q, which we just write as minus q. And then if we look at the ors, then we have minus or plus 2 or, which gives me an answer of plus 1 or, just plus or. So the key takeaways from this part: these 4 key words, so variable, constant, expression, and term, knowing what each of those means. The notation that we use, so instead of multiplying, we just say 2k, and that idea that that number in front of the x tells us how many x's there are. And then lastly, that we can only add or subtract terms with the same variable. So we can only add them together if they have the same letter. And that's because of what we said at the start. When we're adding them together, we're just simplifying how many of those terms we have. So if we have x plus x, altogether I have 2 x's. So that's all we're doing with those points. So in the next parts then we're going to just move on a little bit further and go through some of the other key things then that we've seen.